To write the equation of this piecewise function, I can see that I'm going to need three equations to do that. There's three pieces to this graph. So let's go ahead and begin with that piece in the bottom left of the graph. I'm going to draw on this boundary wall. I can see that something special is happening there, so I'll draw that in there. And I want to write the equation of this ray down here. So it's got a filled in circle, that's important to note, and it continues forever in that direction. Well, I can see that this is just a horizontal line, so the equation of this line, if it was all there, would just be y equals -2. So -2 is that equation. However, I need to include the if part to describe where that behavior occurs. The line is only equal to -2 when I'm to the left, smaller than this boundary wall. So it's got to be when x is less than -3. And I said it was important to note that I have a filled in circle because actually it's when x is less than or equal to -3. So I'll include that equal to bar. If it was an open circle, it would just be less than. Okay? So there's the first piece of this function, the equation of the first piece. Let's take a look at the second piece. This time it's composed of an open circle on that first boundary line, an open circle there, and I guess let me draw in the second boundary line. My graph this time only exists between those 2 points. So I need to write the equation of this line right here. Well, you recall, if you watched the last video, for these lines, they're going to fit into, at least for what we're doing in class, they're going to fit into slope-intercept form, and we're going to have nice integer values, at least for the y-intercept, so they shouldn't be hard to find just by looking at the graph. So looking at this graph, I can see that my slope must be up 1 and then backwards 1. So in other words, a slope of -1. I can see it's a negative slope because that line's decreasing. So up 1, backwards 1, yeah, it seems to work just fine. So my equation of this orange piece should be -1x, and then plus I need the y-intercept. Looking at the graph, I can see the y-intercept was at 4. So -1x plus 4 is this next piece. Remember though, it only exists in a certain location. This time it only exists between the x values of -3 and 0. And so to write that with an inequality, I'm going to say my low end was -3. I wanted to make sure that x was greater than that, and at the same time x had to be less than 0. So if you always go small than x and then your biggest number, you'll be fine. The inequality symbols will face the same way I have right here. Both of these do not have the equal to bar because neither of those circles on the graph are filled in. So there's the second piece of my puzzle. Last up, let's get that final equation. So this time, my graph has a filled-in circle. It does have an arrow, so it continues forever in that direction. I need two things. I need to find its slope, and it appears to be just another simple slope of up 1 over 1. So I've got a slope of 1 this time, and a y-intercept, this time right at the origin, so a y-intercept of 0, which of course I could just say x. I don't need all that. I need my if part though. So where does this graph exist? Where does it behave like this? Well, only if I pick an x value that's greater than or equal to 0, because the graph exists to the right of that stuff. All right, so there are the three pieces that make up the three parts of the graph. To make this into an official piecewise function, all I'm going to do is draw a bracket, a brace, around all of those to group them together and just give it a function name like f of x, and there is the equation of this piecewise function.